There is a shrimp the size of your finger that generates a flash of heat hotter than the surface of the sun. Not a metaphor, not an exaggeration, a real animal living right now in shallow tropical waters, casually breaking the laws of what you think is possible in nature. And the way it does it, even stranger than you'd expect. We'll get to the full mind-bending mechanism in a moment, but first, let me tell you what else is coming, because this story only gets wilder. By the end of this video, you're going to find out why this shrimp creates something that has no business existing outside of a physics lab, what happens to the animals unlucky enough to be caught in its path, and the one detail about pistol shrimp colonies that researchers genuinely did not see coming. Stay with me. Here's where it starts. The pistol shrimp, genus Alpheus if you want to get technical, is a small, mostly unremarkable-looking crustacean. It lives in coral reefs, seagrass beds, and muddy coastal shallows across the tropics. It grows to about 2 inches long. It is not, at first glance, threatening. But one of its claws is dramatically oversized, almost half the length of its entire body, and that claw is where things get surreal. When the pistol shrimp snaps that claw shut, it doesn't just make a loud noise. It fires a jet of water so fast, accelerating to speeds of around 100 kilometers per hour, that it creates a cavitation bubble. Now, cavitation is a word that sounds boring, but what it describes is anything but. When water moves fast enough, the pressure behind it drops so suddenly that the water itself tears apart at a molecular level, creating a tiny vacuum bubble. And when that bubble collapses, which happens in less than a millisecond, it releases an enormous burst of energy. Here's where you need to really picture this. That collapsing bubble, for a fraction of a second, reaches temperatures of around 8,000 degrees Fahrenheit. The surface of the sun sits at about 9,900 degrees Fahrenheit. We are talking within the same ballpark as a star, in your fish tank, produced by something that eats worms. It also generates a shockwave loud enough, around 210 decibels, to stun or outright kill small fish and invertebrates nearby. For reference, a jet engine at close range is about 140 decibels. A rocket launch is around 180. The pistol shrimp beats both of them. And here's the part that still gets researchers excited. For a tiny instant during that bubble collapse, the shrimp also produces a flash of light. Scientists call it shrimpoluminescence, the light produced specifically by the collapsing cavitation bubble from a pistol shrimp snap. It's related to sonoluminescence, a broader phenomenon where sound waves in liquid produce flashes of light. But what makes the shrimp's version remarkable is that it's biological. This animal evolved entirely on its own to harness the physics of collapsing matter. Now pause on that for a second.
Evolution didn't give the pistol shrimp a faster swim speed or sharper claws. It gave it the ability to weaponize quantum-level pressure dynamics. Nature had millions of years to experiment, and it landed on a miniature plasma flash. And here's the thing I promised to come back to. Why does the shrimp do this in the first place? It's not just showing off. This is how it hunts. The shockwave from that snap stuns prey almost instantly. The shrimp doesn't even need to make direct contact. It aims its claw in the direction of a small fish or shrimp, fires, and the pressure wave does the work. The prey is dead or paralyzed before it even registers the danger. It's one of the fastest, most efficient killing mechanisms in the ocean, and it comes from an animal you could hold in the palm of your hand. But wait, here's a fun tangent that earns its place in this story. Pistol shrimp are so loud and so numerous in tropical waters that they have historically interfered with submarine sonar. During World War II, the U.S. Navy struggled to get clean acoustic readings in shallow Pacific waters because the constant background crackling of pistol shrimp colonies was masking the signatures of enemy submarines. Entire military operations were partially complicated by tiny shrimp having arguments on the seafloor. Nature 1, Navy 0. Now, back to escalating this because we're not done yet. Pistol shrimp don't always live alone. Many species have evolved one of the more extraordinary partnerships in the animal kingdom. They share a burrow with a nearly blind goby fish. The shrimp does all the digging and maintenance, keeping the burrow clean and structurally sound. The goby, who has sharp eyesight, stands guard at the entrance. The shrimp keeps one antenna touching the goby at all times. The moment the goby detects a threat and flicks its tail, the shrimp retreats. No threat, the shrimp keeps digging. It is a division of labor between two completely different species, built entirely on trust and touch, refined over millions of years into something that works almost perfectly. And here's the detail researchers genuinely didn't see coming, which I told you we'd get to. In some parts of the ocean, pistol shrimp colonies are so densely packed that the combined noise of their snapping is constant. Not occasional clicks, a continuous crackling roar that blankets the seafloor like static. Scientists studying reef acoustics discovered that healthy reefs actually sound different from damaged ones, partly because of pistol shrimp. The acoustic signature of a vibrant reef, thick with snapping, is a marker for biodiversity. Researchers are now using underwater microphones to assess reef health based on how loud the shrimp are. The shrimp aren't just a curiosity, they're an indicator species for the entire ecosystem. A shrimp that creates plasma flashes is also a sentinel for ocean health.
That's the kind of layered importance you don't see coming from something you could fit in a teaspoon. So here's where we land. The pistol shrimp is 2 inches long. It produces temperatures rivaling the sun. It fires shock waves louder than rocket launchers. It partners with a fish in a symbiosis built on touch. And it is, quietly, one of the tools scientists use to measure whether our reefs are dying. Every single snap, happening tens of thousands of times per minute across the world's tropical shallows, is a tiny act of physics that took millions of years to perfect. The ocean is not a passive place. It is full of violence, ingenuity, and partnership, happening at a scale and speed we can barely perceive. And somewhere out there right now, a 2-inch shrimp just fired a bolt of plasma and killed its lunch before the light even faded. What does it say about our planet that one of its most extreme physical phenomena is being produced by an animal most people have never heard of? Drop your answer in the comments. I read every single one. And if your brain is officially done functioning normally, smash that like button and subscribe so you never miss a fact that makes you question everything you thought you knew about this planet.